All right. Can everyone see my screen? Okay.
Yep.
All right, cool. So we're going to go over Grubhub. So we're just going to pick one of these and go over it. If you can do one of them, you can probably do all of them. So about half of you submitted PRs, so that's good. And we'll go ahead and take a look at this. So the design part here. So we are given some basic requirements, and it's going to be our job to first off, just kind of think in the abstract, create a picture, whether it's, using some electronic tool or a whiteboard or a piece of paper, or God forbid, doing it in your head, probably the worst option. But so we'll just think about how we want to arrange everything, the tables that we want, what we want on the tables, what columns we want on the tables, and how the tables should be connected. So yeah, let's go ahead and get started. So I'm going to use this quick app-based diagram or quick database diagrams. I like the tool, but there's a little bit of a learning curve. So if you don't like it, then that's fine. It can be annoying to learn kind of two things at the same time. Trying to learn SQL and then also learning this similar but not quite the same syntax. But diagrams are very common, like UML diagrams. Especially I think as you get higher up, you'll see more and more diagrams of things, giving you the overlay of the basic architecture. So we know that for this Grubhub, we're starting out with some things, and we're told in the README that this is probably mostly going to be correct, but we're free to modify things as we see fit. So we'll start with this and then see if we need to add anything or change anything. And I'm going to keep this as simple as possible.
Quick question, Chad.
Yeah.
Have you ever used QuickDB like in the field as like for like a presentation or something?
No, I mean I have had to make diagrams, but not using this tool.
It's just like a useful tool that you use to just make tables sometimes.
Yeah, so I mean, this particular app, UML diagrams are just diagramming. It's a general tool. You can use it to model objects like classes or databases. There are other kinds of like diagrams that like network diagrams. I can't think of the term right now, but it'll show you, I make an API call to this endpoint and I get this return value. Then I make an API call to this endpoint. So there's this like chart that shows the back and forth of all the interactions. So there are a couple standard formats that you're likely to see. One of them is something like this. So whether you're doing database stuff or just showing how different components connect, it's not specific to this general structure is not specific to databases, if that's what you're asking.
No, got it. Yeah, thank you.
Okay, so I like to just start out simple and we'll just get all the tables that we need. So again, we're starting with this. We can think through, do we need more or fewer or whatever, but we need order, restaurant, menu item, and user. So we'll do order and I'll make this plural, but I think that's just an optional convention. Orders, restaurants, users, and I would prefer, just for my own convenience, menu item is fine, but I would prefer just to have a one-word thing. So I'm just going to call it dishes. That, feel free to disagree with that choice, but so I've got all my tables here, and there's nothing on any of the tables, and none of the tables are connected. So we can start filling out some of the things on the table. So first thing I'll do, just as a default, is to give all of them an ID. And when we actually implement this, we'll use an auto incrementing ID, so we don't have to worry about it. So ID. I'll just copy and paste that. So we'll make this the primary key for all of them. Okay. So now we have all our things and we have primary keys for all of them. So that's good. You need primary key for a table. It could be either, like kind of an artificial key we're creating here, or it could be the product of some natural feature of the table or combination of natural features of values on the table. Okay, so we've got this, and let's think about orders. Well, let's do users first. That's probably the easiest concept to grasp. So a user, let's just say that a user has a name. And I'm going to keep this as simple as possible. Something like that. So we have a user has a name. Now what about these other things? So before we start, there are a couple approaches to how you can do this. You could start by filling out all of the values on each table. You could start by thinking about how the tables should be connected and then fill out the values. Or you could just do a mixed up thing that doesn't make any sense, which is likely what I'll end up doing. So we got users, and a user has a name. And let's say a user is going to have an order. So users are going to have orders. User probably shouldn't be directly connected to restaurants. Like, why would you care about that? You're ordering food. So I mean, you order food from a restaurant, but really what you're doing is you have a relationship with an order. Dishes, yeah, you can order dishes, but that's more connected to orders. So I think here we can talk about the relationship between users and orders. So there are three basic relationships you can have. There's one-to-one, one-to-many, and many-to-many. One-to-many is the most common kind of relationship. And many-to-many can't directly be modeled in the database, so you have to use what's called the join table. So if you have two things that have a many-to-many relationship, you'll have to create another table and each table will have a one-to-many relationship. So basically, you're limited to one-to-many and many-to-many when it comes down to actual implementation. Okay, so a user. Does anyone have any thoughts here? Users and orders.
So are you talking about like what specifically users should have and what orders should have?
Yeah, what's the relationship between users and orders?
Each order is gonna, or each user is gonna have an order ID.
But more broadly. So in terms of one-to-one, one-to-many.
Users will have many orders.
Many-to-many. Okay, so a user could have many orders. Can an order, how many users can an order be associated with?
That depends.
Yes, we could always make things very complicated, but
Typically, it's just going to be one.
Okay.
And then the person picking it up has to figure out how to divvy it up to all the coworkers.
Yes. Yeah. We can include divide evenly, but don't include tax or something like that. All right. So yeah, a user can have many orders. So I can order 5 different times at different days or whatever, but an order can only have one user. So we can model that here. So we can go into orders. So an order will have a user ID, and that's going to be a foreign key. So now we're creating a foreign key on orders because an order can just have one user. So, and since our columns, for doing normal forms properly, you can only have one value. You can have an atomic value for everything in a column. So we have a foreign key here, and this is just syntax that's peculiar to this, but a greater than arrow, so this is going to indicate a one-to-many relationship, and we're going to connect it to users.id. So here, this may be difficult to see, but there's a single line here. So again, you don't need to know this stuff. I'm just letting you know this is a convention for modeling these kind of things. So this indicates that there's a one-way relationship, and this crow's foot with 3 little prongs indicates a many relationship. So you read this as users can have many orders, and orders can have one user. Okay, so we have users and orders connected. So users and orders. What about, let's say, orders and dishes?
Same deal. Orders can have many dishes, but many dishes can have many orders, I guess.
Yeah, so that's a good question. So orders, let's say we have an order, and the order has, you order 5 different things, so 5 different dishes in your order. And if you have a given, let's say, enchilada plate. So enchilada plate, can you have lots of orders that have the enchilada plate?
Definitely.
Okay. So you can have, it seems like we're dealing with what, I mean, again, we could play around with this and think our way into the one thing or the other, but the obvious answer. What kind of
We have a
relationship?
table.
One-to-one, one-to-many, or many-to-many?
Many to many.
Many to many.
Yeah. So how do we do that?
You can have a table for dishes and a table for orders, and then you could do like orders dishes table.
Okay.
Where you're referencing IDs.
Okay, so let's we were given just 4 things initially, right? But it turns out that maybe this is not going to be adequate for our use case. So we're going to have to create another table. So we'll do order dishes. Okay, so we have another table, and that's somehow going to have to interact with both of these. So order dishes is going to have to be able to connect to orders and dishes. So we'll give it an ID just like everything else. So this join table doesn't really, let's just say it doesn't really need anything. It's just serving as a kind of a dummy table to link these other 2 tables. So it's going to need foreign key relationships to both of the tables. So we'll do orders ID, and that will be a foreign key. And again, that should be a one-to-many relationship, and it'll connect to, what is it, orders.id. And so an order can have lots of dishes, lots of order dishes. And then here we're going to do the dishes. So dishes ID, foreign key. All right, so now we have, so again, so this is like, we know as the designers that this is a many-to-many relationship, but our database can't directly handle a many-to-many relationship. So we have to create this join table that will, that's got foreign keys that connect to both the tables that we want. Okay, so now we have a user, and the user has an order, and an order can have lots of dishes, and a dish can belong to lots of orders. Okay, what about restaurants? So maybe we could just delete restaurants and forget all about it. This seems to be workable.
Well, it depends on if you want this to just be for a single restaurant or not. If you want this to be Grubhub to where they can offer many different restaurants dishes, then you're going to need a restaurant because you could technically have 2 Thai places on your route. And then your pad Thai from this place might be better than the pad Thai from that place, and you end up ordering the wrong one and people get angry.
Yeah, so that's a good point. So it sounds like dishes should be associated with restaurants. You could potentially have, multiple pad thais or something. So let's say that dishes is connected to restaurant. So a restaurant can have many dishes, but a dish can only belong to how many restaurants? Should we do?
It should be many to many as well.
You think many to
Because-
many?
Yes, because everybody's going to sell you a cup of coffee. So if a cup of coffee is is a dish that you sell, and as your Grubhub, and somebody gets a cup of coffee, you're going to definitely have to have coffee from each individual restaurant.
I can see, right. So yes. So depending on how you think of it, I'm gonna do a one to many, but that's a very good point. So it depends.
Okay.
So if cup of coffee is kind of like just coffee period, then lots of places will have coffee. But if it's something like, Starbucks coffee, then, but yeah, so that is a good point, and it probably would be, in fact, more efficient and better to have another many to many table here, so we could make dishes. We'd have less repetition in our dishes column. Although it kind of depends on how you think about it. So it's possible that, since every coffee, is unique, every coffee will be slightly different. Every enchilada dish will be slightly different. That all of, even if it's just enchiladas or coffee, they're all kind of unique instances. So
every dish is unique because every dish has a separate different price. So even though everyone has coffee, everyone charges a different price for coffee. Therefore, every ordered dish is unique.
So that's another good point. We could also just have another price table and connect those as well. Yeah. So just for the sake
So
of
I guess
simplicity,
if you're talking about it and your cup of coffee has a description, that would make it unique, because like you said, everybody's cup of coffee is going to be slightly different. So you wouldn't necessarily have to do the many to many table. And for this example, if we're just talking about a handful of different restaurants, then it's definitely reasonable to attach it that way and just make the descriptions of the items different enough to where you would, and I guess also when you're clicking through this, you're only going to be getting responses from a given restaurant. So you would be getting that restaurant's coffee versus whatever. So that would help the user not have to worry about it.
okay. Yeah. So I think the moral of the story is there's multiple ways to do any of this stuff, and it will depend on kind of your use case and what you think your use case might be, and we might have to, if we were getting this, as a requirements from a customer, we might at this point want to go send someone an email and double check what they actually want and how specifically they're envisioning this. For now, just to keep this as simple as possible, I'm going to make this a one to many, just to minimize the number of tables we have to create. So we'll add a key on dishes. That will be restaurant's ID. That's a foreign key. And that's going to point to dishes. Yeah.
I ended up adding a driver class. You think that was necessary or no?
Sure. Yeah, you could definitely. I mean,
Driver table.
you have a driver, associate the driver with the order. So yeah, This right here is like basically the simplest possible way to do this that I could think of. But it doesn't mean it's the most realistic way. So yeah, if you are actually thinking about designing this, you could make this much, much more complicated. And yeah, it's just like designing a class, right? So I have a class that's supposed to, I don't know, a class to handle Caesar cipher. There's a lot of different ways that you could design that. You could have one method, you could have 10 methods, you could have subclasses, you got different hierarchies. But so part of this is just a lesson on thinking through it and being able to talk about it and why you're doing one thing over another. So if this were an interview question, the interviewer is not cared. The interviewer doesn't care about actually implementing this because they're not like going to take your sketch that you do and go start coding. It's just to see how you think. So I think this should be good enough for now. So now that we have our connections and everything, we can go ahead and fill out some of the detail. So I'm gonna be very bare bones here. So orders, let's do restaurants. We'll have a name also. And a user will have a name. Dishes, let's just also say name. We're gonna be very boring. Order dishes, and an order, let's just say it has a total. So again, I'm simplifying this a little bit, but so let's say total, and this will be, I think there's a money type we can use in Postgres. So I think this is kind of the minimum bare bones to get something that works. So we have a user. A user can have many orders. An order is associated with one user. An order can have many dishes, and a dish can be associated with many orders. And a restaurant can have many dishes, but a given dish can only belong to one restaurant. Again, in the way we've modeled this. Okay, so I think that's good for schema. Let's start coding some stuff. So I'm going to clone. Oh, I should fork it, I guess. I'm just going to skip that because I think we all know what the deal is. Well, actually, maybe I should do it. I'm going to probably have to delete my repo. Hope no one's listening to the clicks and figure out what my password is. All right. Let's just go back. Schema design, I'll fork it. Now I'll clone it. All right, so I've got schema design. Schema, this really isn't doing anything for us, but it will enable me to push up a partial solution. So what I'm gonna do here, I know this is not technically part of this exercise, but we're psychop 2, so using Python to handle. So I'm gonna go ahead and do this using that, and the basic SQL will be the same. It's just wrapped around something else. So you should be able to follow even if you haven't seen the lecture. But the reality is you're not going to be making SQL queries directly in this course, at least. Okay, so I'm going to create a virtual environment. Let's see. So I'm creating a virtual environment and I'm going to install Psycop so I don't have to install it globally. If you don't know what this is, there's a lecture on it for today that you can watch. And I'm going to add a git ignore. So okay. All right. So I've created my virtual environment. Now I have to activate it. So source. All right. Computer is being slow. Okay, so now I've activated my virtual environment. Again, if this doesn't make sense, you'll watch the video today and it should make sense. So now I've created an isolated environment. So when I install stuff, I'm not installing it globally, which can lead to problems down the road. So pip install.
Chad, can I ask you about that, or should I just wait for later?
Sure, go ahead. Yeah, I've got like 10 seconds while this installs.
For the virtual environment, is that just the way it's done in Python compared to if it was like a JavaScript, or we could just install modules only in our project?
Yeah, so in Node project, it should by default essentially do the same thing.
Mm-hmm.
I think in older versions of NPM, you had to specify where you were installing it. But yeah, so if you have a Node project and you install a module, it should just be local.
Okay, so this virtual environment thing, it's like a Python thing that we need to do, right? So we only install modules to the project.
Yeah, so I mean, you don't need to do it. You can get away with not doing it. The problem is eventually, if you install enough modules, you're going to run into an issue. And it's probably going to be a difficult issue to fix. So just to keep your global environment nice and clean and tidy, it's best to create basically one virtual environment per project that only has what you need for the given project.
Okay, thank you.
All right. All right, so let's look at Grub. All right, so we got my the Grubhub.py, which should probably go in here. All right, so Grubhub.py. So what we're going to do is we're going to create a database. So we'll go ahead and do that on the command line here. We'll just create a database, and then we'll start executing commands. We'll start writing commands that will allow us to create all the tables that we need to create the schema. And then we can populate it with some data maybe and try running a search. So we'll do and if this doesn't entirely make sense, that's okay. So the lecture today should clarify it. So I'm going to use a with statement, and this is going to create a connection object. So you can basically ignore, if you're not familiar with this, you can just ignore all this part. I'm just going to actually copy. This is kind of boilerplate. So everything we do after this will just be SQL commands. So if you know SQL, you should be able to follow with the rest of this. And Okay, so we're gonna cur.x. So here we're doing is we're connecting to a database. So we're actually creating an instance of a connection object, and then we're creating a cursor object. And again, you can watch the videos for today, and that will make more sense. But here we're actually just going to we're going to pass in a string that's a SQL query. So from this point on, things should make sense. I'm going to create this database.
Chad, is that os.get login a different way to import the username instead of just typing it out?
Yeah, so you could do either. This is just more of a, so you don't have to hard code it. So it's just a dynamic way of getting the.
Cool, thank you.
Yeah. Mm-hmm. Okay, so I've created my Grubhub. You can call this whatever you like, but that's just calling it Grubhub. So now we're going to do is execute some SQL queries. So we need to create tables, right? So that's basically, so there are three kinds of SQL, operations that we care about. We want to create tables. We want to insert things into tables, and then we want to select things from tables. So here we're going to create. So create table. So we can start with users. So the order that you do this in can make a difference. So I'm going to start with things that, so if I try to create orders first and there's no users, and it's going to want user ID. So that's one reason to use alter table statements to kind of divide up the creation process. You create all your tables, and then once they're all there, you have a bunch of alter table statements where you can add basically information about how they're connected. So primary keys and so on. But I'm going to do it a slightly lazy way. It's a little bit less typing. So the order will be important. So I'll start with users. We don't want to get issues with dependencies. So users and retail users, and we have so an ID, and that will be a serial. This is just for Postgres. So primary key, and so the user is going to have a name, and that's going to be varchar 50. This is just kind of an arbitrary thing we're doing. And then we're going to do something similar. So we're going to be creating a whole bunch of tables. So we got users. We can create orders now. There are no dependencies, so order is also going to have the serial ID primary key, and an order will have not a name, but a total. And that should be money type. And users, so I'm going to go ahead, because there are some dependency issues with these two, dishes and order dishes. I'm just going to go to restaurants, create restaurants next. And that will have, again, ID serial primary key, and name, I think it's just going to have a name. Yep. So that's all we have to worry about there. Now I'll go ahead and go to dishes next. That's going to have the serial primary key, and the dish will have a name. And is that it? Dishes will have a name and a restaurant's ID. Name. Oops, restaurants ID, integer, references, ID. Okay. Okay, so we also have a primary key. Sorry, skipped one. So users, so orders also has a primary key, which is going to refer to users. So orders, total money, and then we're going to have user ID. That will be an integer, references, users ID. So all this stuff should look pretty familiar. It's just SQL. Okay, so we create users, orders, restaurants, dishes, and the last thing we need to do is our join table. So that is order dishes. That's going to have an orders ID and a dish ID. So integer references will be orders ID, and then an order ID and a restaurant. Sorry, I forgot. And orders and dishes. So D. All right, so we're creating all of these tables. That looks right to me. Anyone see any obvious errors?
For consistency, dishes ID should be dish ID.
Okay, cool, thank you. Dish ID, we got user ID, yes. Okay. So we can give this a whirl. We might have to make some adjustments, but that's okay. Syntax error at the end of input, create table users.
You need to add a semicolon in there. I think.
Yeah, you don't have semicolons at all.
I don't have semicolons, but that shouldn't make a difference. I believe that those are added by default. Cool.
It looks like you're missing a closing parentheses.
So something.
Yeah.
Same thing
That's probably the case on all of
line
them.
9. Yeah, I guess it's gonna be the case on all of them.
Yeah. So doing this as just strings is, you don't get all the linter support. Okay, it looks like that worked, but we don't really know because we didn't get any output, but there are no errors. Let's go ahead and go into our database and check it out. So PSQL. And D. All right, so it looks like we have some tables. We have dishes, orders, restaurants, users. So that looks good. Looks like that worked. What happens if we try to run this again?
It should error because that already exists and you didn't tell it to drop it at first.
Yeah. So for development purposes, it's usually good to include some drop table stuff just to make your life a little easier. So cur.x. So what should I type in here?
Drop database.
So I don't
exists.
Yeah, so I don't necessarily want to drop the database, but I want to drop
The table.
yeah, I want to drop
Okay,
tables.
so then drop if
I mean, I could drop the
table
database.
exists.
That would probably be easier actually, but drop table
If exists.
and then And is there another thing that I might want to?
Cascade.
Yeah. So it depends on your use case, but probably Cascade is the sensible default.
You can also add the cascade to each individual field as well. So like when, rather than just applying it to a database or to a table, you can specify the cascading of a particular thing to function, but not another, by addressing it as the individual reference on
Okay.
cascade delete.
Cool. Yeah, that's good to know. We'll just do mass destruction this time. Okay, so I run it again, still no errors. So I'm gonna assume that this is working now. Okay, cool. So we've got our schema. So we planned it out and now we have it implemented. So you could try adding some data. And I'm gonna have some of this so you don't have to go through all this time consuming stuff. If you should know how to write insert queries as well. So I think I kept everything the same. We'll find out if it blows up. So we're gonna have to go through the same process. So here, when we create the thing, we create this connection and then a cursor and all this other stuff you can hear about more later, but we have to repeat all this process. So we have to create a new connection to our database and then insert all of these values in here. So again, the insert statements work the same way. So we're inserting into table name and then the values, and technically we don't need to specify this because we're inserting all of the values for every column, but I specified all of them. So insert into table and then column names and then the values. So it all works the same as in normal SQL, except you don't have to worry about semicolons, which is nice. So let's try running the insert the Grubhub data. Into dishes. Okay. Column restaurant ID of relation dishes does not exist. To dishes. Probably a naming issue. Restaurant. Restaurants ID. Restaurants. Yeah. So let me just make this plural.
Your other one is pretty consistent with not plural.
Yeah, this probably makes more sense to just change it here.
And then you'll just have to rerun your database build.
Okay. Computers. Okay. All right, so it looks like that works. So we can go ahead, again, we can go into our database and just check it out. So PSQL Grubhub and SD. Okay, so let's do a select statement. So if I want to see everything in the dishes column.
Select flat from dishes.
Somewhat, I appreciate, but I want to hear from
All right.
someone who's falling asleep. Who's falling asleep? Who's got the camera off? Isaiah Bragg. Isaiah Bragg. You're on the spot.
Hello, what was that? Sorry, I missed it.
So how do I see all of the values from my let's say users table?
How do you see all the values of the user table? You're going to do, it looks like you're already in your database. You do a /D and then the users. And
Okay.
I'll show you all.
So that'll show me the format of the table, like the basic structure of the table. But if I want to see each individual user in my users table. So how do we query information from a table?
Oh, yeah. So you're going to want to do the select or select star from users. Yeah.
Okay.
And that will give you everything in users.
All right. So my computer is being very slow, and I will have to include a semicolon here. Right. Okay. So so that worked. Thank you very much. Sorry to disturb you. So now we can see that our data is actually in the database. So if we wanted to run more complex queries, we could certainly do that, but I think that kind of gives us the point. We could also write yet another script, like a query script, and follow the same format, where we're connecting, and then we just write our queries in there, and we can display them. So that's basically the long and short of it. Started with our requirements here, and then we tried to model them. We ended up adding something, so not given in our requirements. And then when we went to implement it, we just followed that good old SQL syntax, and everything worked. So are there any questions?
Yeah, so instead of doing all of the create table and drop table statements and strings like this, is it possible to create like a create schema.sql file, import it, and then just do one cur.execute and call that file?
That's a good question. You could probably do that. I mean, if you wanted to just run it as a script, you should probably just be able to use normal, like Python, just read the contents of the file and then execute the file as a, so it would essentially be a string. It would just be a string of the entire file. So I haven't tried doing that, but I'm sure you could do that. Yeah. Okay. If there are no questions, then I will stop. And
I do actually have a question.
okay.
So the scicop G2, that's, I guess I don't see the point in this versus just running an SQL file.
Yeah.
So what additional capabilities does that give us?
So that's a great question, and I try to answer that question with one of the videos for today's lecture. There's an example
cool.
web application, but the short answer is I can't have a web application and just have SQL. So I have to somehow get from entering a user entering something on a form on an HTML page all the way to a query in a database. And
I see. So this is also going to act as our middle layer for that.
Yeah.
I guess so from my perspective, I would just create an SQL script to do the creates and then utilize this for the communication back and forth.
Yeah.
Mm-hmm.
Okay.
And when we learn Django, is the syntax going to change for executing SQL queries? Or is this pretty much what it's going to still look like?
So it will not look like this. So there'll be another layer of abstraction.
But we would still need to use this scicop PG2.
So under the hood, Django uses that and probably some other things as well. But Django itself, you won't be writing actual SQL when you use Django.
Like not even create table, whatever users, like not at all.
No.
So yeah. Oh yeah, go ahead.
No, go ahead, Tom.
Yeah. Oh no, yeah. So Django, has a built-in ORM. I'm sure you heard that acronym on Tuesday, Object Relational Mapping. Essentially, you're able to write Python codes using methods or built-in methods in Django that essentially converts that into SQL queries, as well as you're able to create your tables using classes and all of that instead of just writing raw SQL. So that's what Django is useful for as well.
Okay, so for today's material and lecture, it's one of those, we don't have to, like for us to be familiar with it, but so we can understand what's going on, but not like.
Exactly.
You know what I'm saying? Okay.
Also, a good benefit of using Python in this form is just, for example, I think in one of your challenges, like if you have a CSV file with a bunch of data in it and you want to convert that or insert that into a database, you can read from that CSV file using Python and then write Python, connect to your Postgres database using scikop G2 and do like a for loop through every single one of those lines in your CSV file and insert that into the database. So instead of having to manually write that, you can write a script that does that really quickly and fast for you.
Thanks for that. Yeah, because that definitely gives me a better understanding of why this is useful.
Yep.
Okay, so I think at this point we're good here. Stop